Hi everyone. My name is Helena. I'm a PhD candidate of the New University of Lisbon. I'm so excited to talk to you about my research idea for the American Corner Contest. Soil contamination is a major environmental issue worldwide. In North America and Europe, the extent of contaminated land is best known, with many countries having a legal framework to identify and deal with this environmental problem. In the United States of America, as many as 350,000 contaminated sites will require cleanup over the next 30 years, assuming that current regulations and practices remain the same. The bill for this cleanup may amount to as much as $250 billion. In Europe, an estimate points to 242,000 contaminated sites. Developing countries like China and India are also struggling with this environmental problem. Since the late 90s, with the nanotechnology's boom, zero-valent iron nanoparticles are considered very promising for soils and groundwater remediation. Due to their high surface area and consequent reactivity, they can attack a wide range of contaminants, especially chlorinated organic compounds. The last 10 years have seen over 50 pilot or full-scale applications of iron nanoparticles for in-situ groundwater and soil remediation worldwide. Most of the pioneering fieldwork was conducted in the United States, while interest by European countries is picking up, with 15 field demonstrations and full-scale implementations completed. The EU adopted a precautionary approach. We should study more this new technology before releasing the nanoparticles in the environment. In fact, we currently don't have a method to measure and quantify iron nanoparticles in soil. The usual methods to characterize nanoparticles are based in electron microscopy, like scanning electron and transmission electron microscopy, as well as transmission X-ray microscopy, are time-consuming and require expensive equipment and expertise. There is an urgent need for an expensive and portable instrumentation for the detection and measurement of iron nanoparticles. So, I had an idea. Why not using hyperspectral imaging to analyze iron nanoparticles? This technique has been used successfully in food quality and medical applications. Remote sensing uses hyperspectral imaging to obtain detailed mineralogical, chemical and morphologic information of the Earth's surface. What I'm suggesting is just to adjust the scale of the application. Instead of using hyperspectral sensors in satellites and airplanes, use a portable camera to identify zero-valent iron and iron oxides in soil samples directly in the field based on their spectral signature. Wouldn't that be great? This would allow us to identify proof nanoparticles in target media, like soil, to monitor nanoparticles' environmental concentration trends, to study behavior and fate for nanoparticles, both in lab and field tests, and also to validate predicted environmental concentrations from exposure or life cycle modeling. With this data, we could assess if the use of nanoparticles for soil and groundwater remediation has significant environmental impacts and limit its application or make it more sustainable. Thank you all for listening, and I hope you liked my idea. Bye.